Hello everyone, I hope you all are doing good. In our today's video, we shall solve some of the simple numerical problems on the chapter electricity. So we shall take up the first problem. What is the first problem is a steady electric charge of 60 coulomb flows through a filament of bulb for 2 minutes. Find the amount of electric current flowing through the circuit. So whenever the problem is given, first you have to write the data. So what all they have given? Charge. Charge is Q, which is equal to 60 coulomb, and time is 2 minutes. So if they have given in minutes, you have to convert it into seconds. So 1 minute equals 60 seconds. Therefore 2 into 60 equals 120 seconds. And here we have to find out the current, that is I. So the formula to calculate I is I equals Q by T. The Q is nothing but charge 60 divided by time 120, which is equal to 0.5 amperes. Next question. An electric bulb draws a current of 0.5 ampere for 10 minutes. Find the amount of electric charge that flows through the circuit. Here we have to find out charge Q. The data given is current, that is 0.5 ampere, and time is 10 minutes. Again they have given in minutes, you have to convert it into seconds. 10 into 60 equals 600 seconds. If they have given in seconds, no need to convert. Otherwise you have to convert, because you have to solve the problem keeping in the SI unit. And here you have to calculate charge, that is Q equals I into T is the formula. You will substitute the values for current and time, that is 0.5 into 600. The answer is 300 coulomb. Next question. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt? Here you have to find out work done. So the data given here is charge Q equals 2 coulomb and the potential difference V equals 12 volt. Work done you have to calculate. So you know the formula for potential difference, that is V equals W by Q. So W is nothing but work done. So W equals V into Q. Substituting the values for potential difference and charge, that is 12 into 2, you will get 24 joules. Next question. A battery does 200 joules of work to move a charge of 25 coulomb through a circuit. Calculate the potential difference across the battery. If this charge moves in 10 seconds, find the current. Here you have to calculate two quantities. One is potential difference and another one is current. So first we have to note down the data. That is work done is 200 joules and the charge Q is 25 coulomb and the time is 10 seconds. Here no need to convert because they have already given in the seconds. Next, here we have to calculate the potential difference. Formula is V equals W by Q. So substituting the values for W and Q, that is 200 divided by 25, the answer will be equal to 8 volt. And they have also asked to calculate the current, that is I equals Q by T is the formula. Substituting the values, that is 25 divided by 10, the answer is 2.5 amperes. And the next question. A 9 volt battery is connected to a curling iron with a resistance of 18 ohm. How much current is flowing through it? Here you have to calculate current. So first we have to note down the data, that is the potential difference or the volt, it is equal to 9 volt and resistance is 18 ohms. Here you have to calculate the current. So the formula used is I equals V by R. here you cannot use I equals Q by T because the charge and time is not given. So while using the formula, first you have to see the quantities what they have given, and then you have to apply the correct formula. Here the voltage or the potential difference and resistance is given. So here you have to make use of the formula I equals V by R, that is the Ohm's law formula. So substituting the values for V and R, that is 9 divided by 18, you will get 0.5 amperes. Next question, what voltage is required to produce a 0.35 ampere current through a 750 ohm resistor? Here you have to calculate voltage V. So the current is given to be 0.35 ampere, resistance is 750 ohm, and the formula to calculate voltage or potential difference is V equals I into R. So substituting the values, you will get 0.235 into 750, which is equal to 262.5 volt. And the next question, a hair dryer draws 6.5 ampere of current when plugged into a 120 volt outlet. What is the resistance of the hair dryer? Here you have to calculate resistance R, and they have given current to be 6.5 ampere and voltage is 120 volt. So the formula to calculate resistance is R equals V by I. So substituting the values, you will get 120 divided by 6.5, which is equal to 18.46 ohms. So these are some of the simple problems you may get for 2 marks or 1 mark in the examination. Here you are applying the formula and directly substituting the values. So these are the important formulas and problems you may expect in your examination. I hope you find this video useful. If you have any doubts, please comment in the comment section. Thank you.